if we use, again, if we use a exact differential equation, it could be, if we use homogeneous differential equation, it is actually an overkill. So it will just making your life hard. So let's, actually the answer for this one is simply a variable separable method. So from here we could just separate, okay, separate and combine those variables, that is variable separable. So dy, so transfer here, so cross multiply. So we have dy cross multiply. So we have, just let's just remain the negative 2, so that dili na ta libog pa. So you have y here, and the dx just remain the negative 2 dx over c minus 8x. Kay para dili kayo siya confusing, kay when we solve negative ln here, so to the power of negative, so pwede ra pod actually, or mas better dili na pod. Okay, so from here, if you could see, if we form this one as transfer this one, so to the other side, so to follow the general form, the mu of xy dx plus n of xy dy is equals to 0 for the general form of the first order, first degree differential equation. Then we'll transfer this one to the other side. So from negative, moving to the other side, it becomes positive 2 dx over c minus 8x equals, so wala man nato gibal, sorry, not equals, so mag-uban sila, so this becomes plus dy over y equals 0. So if you could see, you have dx, we have x, we have dy, we have y. Therefore, we can now apply your integral calculus. Okay, integral calculus. So from here, you need to integrate. So we can put the constant outside over c minus 8x plus dy over y was integral of 0. After that, this, we know this is ln y. So here we can use u as our, c is a constant, so you have c minus 8x. Okay, so okay, so your du is equal to a constant, derive a constant that is 0, derive this one that is negative 8 dx. So therefore your dx is just equivalent to du over negative 8. So after that, let me transfer it here. Okay, so from here, let me, oops, okay, so from here, let's transfer. So we have 2 integral, what is our dx, that is du over negative 8. Sorry. Okay, sorry. Okay, so what is our du, that dx, that is du, so our dx is equivalent to du over 8, negative 8. So du over negative 8 over c minus 8x, that is our u. Next, we have dy, integral of dy over y equals integral of 0. After that, we could move this 1 over negative 8 to the other side. So you have 2 over negative 8 integral of du over u plus integral of ln u, sorry, not ln, dy over y equals integral of 0. So after that, so simplify this one, this is negative 1/4. So we have ln of u plus integral of dy over y, that is ln of y. So to be easier, we make this one out as ln c. So from here, we just need to we can multiply it by 4, or just make it like that. So we can multiply it like, for example, multiply it by 4 so that there's no reciprocal, so, or fraction. So now you have negative ln of u plus 4 ln of y equals 4 ln of c. After that, we need to substitute the value of u. So what is our u? We have negative ln of c minus this one, negative 8x plus, so our ln becomes the power of y raised to the power 4 equals ln c raised to the power 4. So this c now is c sub 1. Let's make this one so that na ay differencia with the c of this. Basin ma-confuse na to, itapo na to niya. So this is the constant which is different. So from here, we can, because this is a negative, this is a positive, we could make it like ln, the positive will be on the up numerator, the negative will be on the denominator, right? Okay. It doesn't mean na negative ni siya, so then this one between them is plus, so i-multiply mo, but the other one's negative, so that's not the case. So if the other one is positive, the other one is negative, the negative one will be the denominator, equals ln c sub 1 raised to the power 4. So from here, we could have y raised to the power 4 over c minus 8x equals e raised to the power of ln c sub 1 raised to the power 4, and we know this is equal to 1. Sorry, that is 1. Okay, so that is 1. So therefore, you have y raised to the power 4 over c minus 8x equals c sub 1 raised to the power 4. And, okay, let's move. So, and from here, we can get our equation, which is y raised to the power 4 is equal to c sub 1 raised to the power of 4 times c minus 8x. Okay? So, let's look if we have different answers. Okay, let's try to check. So, if you could see, our answer is y raised to the power 4 equals c sub 1, okay, for here, okay, c, okay, c sub 1 is supposedly from here, so we could actually write it like y raised to the power of 4, sorry, or let c sub 1 raised to the power 4 equals c sub 2. So from here, I forgot to write the 1, so I corrected it here so that we are not confused to knowing that this c is just equal to this c. Okay, they are not equal. Okay, so from here you have an equation of y raised to the power 4 equals c sub 2 times c minus 8x. Okay, so let me change the color of the final answer. So therefore, this is the equation of the trajectory in order to hit or to touch the tangent point at this equation. So in this equation, man yung gikinanglan nato para magka-form sila og 90 degrees. Okay? Or this could be rewritten as kini, because I've actually in this part sa ato ang notes, so I've actually written it when another solution, if you don't multiply it by 4, so if you retain it with 4, so you will have this one, and the 1/4 will be raised to the power of u, it becomes 1/4, so it becomes like this. So from there, you have raised to the power 1/4 ln, and after that you have this 1/4. So if you could see, if you could see, this just if you transfer it to the other side, that is the square root or the root of 4 sa ani, which is this one, or raised to the power of negative, raised to the power of 1/4. So kini balhin ni ba, di ba, kung y squared yung transfer it, that is 1/4, one ano man kanang gani kanang what you call this, square root. Okay, so this is just 1/4. Okay, so that is simply the isogonal or orthogonal trajectory. So the difference lang nila is the equation that you will be using. Okay, but the process is the same. So let's review. Okay, let's review before we end of this topic. So the first thing we need to do is to derive the given equation. After deriving the given equation, you need to get that slope. So after you get the slope, so this is the slope of the given curve or this ellipse. So after that, use the slope in order to get the other equation or the trajectory that touches that curve. Okay, so in this case, it is ellipse. So, and remember, if that is a isogonal trajectory, then the equation that you will be using is the slope is equal to tangent P is equals to M1 or M2 minus M1 over 1 plus M2 times M1 or M1 times M2. But in orthogonal trajectory, then we know that is 90 degrees, so this is perpendicular, and we know that in order to get the other slope, so in order to get the other slope, and in this case, we always get a slope from the given curve. So in order to get the other slope, it is just the negative reciprocal of the given curve. So from there, just substitute it and then simplify until you reach this one. So in this case, na-simplify siya. Again, this is not always the form of the equation. So it depends. So until you simplify this given equation, it could be variable separable, or maybe the result of that becomes homogeneous, or any type or any methods that you could use. You just need to look into that equation na unsay angay na method ang gamiton. So in this case, it's just very simple because we just use the variable separable. So isogonal, matong medyo taas siya because we've used, kung sa gigamit nato ato, linear ata, di ba? Marag linear man siguro itong nagamit nato atong isogonal. If I'm not mistaken, linear ba or Bernoulli? Homogeneous. Homogeneous na ito nagamit nato ato. Okay? So in this case, that is just variable separable, separating those all x and those all y's. After that, we just need to, after separating, we go back to integral calculus. So these are the process of integral calculus. So please recall. So after that, just simplify and you will have the equation of the trajectory. Okay? So, any questions? Okay. So for this will be the last part of the application of the geometric application, or this will be the last part of the geometric application. The next session or the next topic will be about the physical applications. So those are applications where the result is not anymore equations, but you have the exact value from the given equation. So you will substitute mga values and you will get the constant, you will get the arbitrary constant values, then substitute everything to those until you get the exact result. Like for example, you are asked to solve for how much salt remains, what is the temperature after 10 seconds or after 1 hour or 30 minutes, or what will be my investment